The goal of our lab today is we're going to look at Ohm's law, but more importantly, we're going to try to understand how a circuit board works. So really quick, you can read, so I'm not going to insult your intelligence in terms of the lab here, but I'm going to give you a quick tour here. So the first thing is, if you look at your circuit board, there's some basic components. We have a battery compartment where you put in the batteries. You got 3 light bulbs. This little knob here, when you turn it, it's called a rheostat, is a fancy word, or potentiometer. It's a variable resistor that changes the amount of resistance. This is transistor. We're not going to use that, but all of modern life started with this, transistor radios, and now you have microchips. You store thousands of little switches, hundreds of thousands, on a little piece of silicon wafer. And then you have little springs. So the first thing is, it's very low tech, but the way you make a connection is you just slide it right into the spring. If the spring is loose, you can give it a little squeeze there. The other thing is, when you grab the board, don't grab it by like the light bulb or the battery holder because you'll rip it out of the socket. But if you grab it by the edge and you peek on the bottom, the circuit board components here, there's literally wires that are printed inside this piece of plastic, and then the little silver blobs you see here, this is called solder. You literally melt liquid metal onto the board there to make connections. In real life, circuit boards, printed circuit boards, is how we connect lots of components efficiently, like on a cell phone, on a computer. That's called the motherboard, where you make all the connections, etc. So that's a quick little tour there. Next, when you look over your circuit board there, you should have 7 wires, and I'll come around and make sure you have 7 there. If your battery drops below 1 volt, then show me real quick, and then we'll get you a new battery. How can you check your battery's voltage? Use the voltmeter, right, on your multimeter there. So the first part of the lab, here's what's going to happen here. Notice there are 2 battery holders right here on our diagram. There's point A, which is the top of the battery, point B. These 2 points, C and D, are right below the battery. E and F is the top and bottom of the light bulbs. And then I, J, G, H is at the bottom there. So what does all that mean? All we're trying to do is represent this circuit board abstractly as a diagram. So the first thing you want to do is you want to pull out the batteries gently. You don't want to just rip it out because you'll rip the socket loose. There's these little plastic tabs you pull out so that you can slide them out. So just pull them out nice and gentle. When you put them back, okay, this is important because it already got screwed up. They only go one way, and that is if you look inside, the positive end goes down, the negative end goes up. If you put it in backwards, you just screwed up your circuit already. It's not going to work because then your batteries are pumping the wrong way. So pay attention. Here's what's going on. The very first thing you're going to do is you're going to figure out how is point A wired to the rest of the board. Is point A wired to B? Is it wired to C, D, E, F, H, G, I, or J, okay? I'm just trying to look at the diagram on the sheet here to see how they match up there. So here's how you can check. You guys remember how to check to see if things are connected? You set your meter to the secret conductivity tester, the music one, at 5 o'clock. Shove in the plug where? On the amp side or the volts ohm side? Which one? The volts ohm side. Volts ohms music, and then amps is only on the left. Everything else goes on the right. Make sure it's in tight. Then what happens is, if all goes well, listen, here we go. You have a connection, right? So where is this point wired to on my board? Is it wired to B? Nope. Is it wired to over here? Beep, down here. This is point C. If all goes well, we should see that A, let's find out, is wired to C. Perfect. So in other words, you see how this is even labeled negative end of a battery? Yeah? When you stick a battery in here, it's wired underneath the board. If you actually peek, it's wired underneath to that spring clip terminal. So what does that mean? That means when you want to connect to the negative end of the battery, there's always a bunch of people who they're too eager to play and they don't really know how this works. They do like weird stuff, like they shove the wire in here, they wrap it around this post. That shows you don't really understand the board. All you do is you just stick a wire there. That's how you connect to the negative end of the battery. Because as long as metal, touches metal, you have a connection. So point A right here is wired to C. So what does that mean? Let me show you what that means. All that means is, if you look at your circuit board, if you want to connect to the negative end of the battery, see how the negative end goes up, the positive end goes down? Metal touches metal is wired to metal. I would just slide a wire into the spring, and I have a connection to the negative terminal. Where is point B wired to? Point B is wired to where? Right here, right? Point D. Put that on the chart. B is wired to D. Notice that point E is wired to point F to the light bulb. G is wired to H, and I is wired to J. The light bulb is wired to the socket. When you screw this into the socket, the side touches the side terminal, the bottom touches the bottom, and then it touches these 2 springs. That's how you connect to each side of the light bulb. Down here, These are called jumper terminals. They're wired to each other underneath. How is that helpful? If I want to make a connection all the way to here and it's too long, I don't have a wire big enough, I can do what's called a jumper, where I connect to one of the corner terminals down here, and then it's like jump starting a car literally. I can extend my wire by connecting to the other corner. There we go, like so. And then I could connect, say, to the negative end of this battery, etc. Okay? So literally what I did is I connected the negative end of battery number 1 to the negative end of this light bulb here. You see that? Because it's connected through this jumper terminal.